Hi! Today, we will learn about multiplication of radicals. Our objective is to multiply radical expressions. To simplify expressions involving products of radical, you can use this property. If a and b are real numbers and a is greater than or equal to 0 and b is greater than or equal to 0, then the nth root of a times the nth root of b is equal to the nth root of a times b. In general, the product of the nth root of two or more real numbers is the nth root of the product of the numbers. Let's have some examples. Multiply and simplify square root of 7 times square root of 5. Now this is the same, or this is equal to square root of 7 times 5. And that is square root of 35. This is now the product of the given radical expressions. Let's have another example. Multiply and simplify 12 square root of 3a times 4 square root of 4b. First, we multiply 12 and 4. And then multiply the radicands 3a and 4b. 12 times 4 is equal to 48. 3a times 4b is the same as 4 times 3ab. Now 4 is a perfect square, and the square root of 4 is equal to 2. Now the radicands 3ab will be left inside the radical sign. Next, 48 times 2 is equal to 96. And then bring down square root of 3ab. This now will be our product. Let's have another one. Multiply and simplify 8 square root of 10m times 5 square root of 2m. So first we multiply 8 and 5. And then multiply square root of 10m and square root of 2m. So we have square root of 10m times 2m. 8 times 5 is equal to 40. And then we have square root of 10m times 2m is 20m squared. If you will try to observe, 20 still has a factor which is a perfect square. So the factor of 20, which is a perfect square, is 4. So 20 is the same as 4 times 5. So we have 4 times 5 times m squared. 40 times the square root of 4 is 2. And the square root of m squared is m. And then 5 will be left inside the radical sign. For our final answer, we have 40 times 2, 80. M square root of 5. This is now the product. Another example, we have multiply and simplify cube root of 18xy squared times cube root of 6x to the 6th power y to the 4th power. So first, let us multiply the given radicand. So we have cube root of 18 times 6 times x to the 6th power times y squared times y to the 4th power. 18 times 6 is equal to 108. X times x to the 6th power is x raised to the 7th power. Y squared times y to the 4th power is y raised to the 6th power. So now we will think of a factor pair of 108 in which one of them is a perfect cube. So the factor pair of 108, wherein one of them is a perfect cube, is 27 times 4. And then we will split x raised to the 7th power, wherein one of them is a perfect cube. So we're going to have x raised to the 6th power times x. And then for y, since it's already y raised to the 6th power, since it's already a perfect cube, no need to split it into factors. So this expression now is the same as cube root of 27 times cube root of 4 times cube root of x to the 6th power times cube root of x times cube root of y to the 6th power. So let us underline the factors which are perfect cubes. 27, x to the 6th power, and y to the 6th power. The cube root of 27 is 3. The cube root of x to the 6th power is x squared. And the cube root of y to the 6th power is y squared. Now, 4 and x will be left inside the radical sign. So we have the cube root of 4x. This is now our product. 3x squared, y squared, times the cube root of 4x. Multiplying radicals having different indices but the same radicand. To multiply radicals of different indices, it is necessary to change them into equivalent radicals with the same index. Say for example, we have simplified square root of 2 times cube root of 2. So in order to multiply this, let us first rewrite each factor in exponential form. Square root of 2 in exponential form is 2 raised to 1/2. And cube root of 2 in exponential form is 2 raised to 1/3. So we now have 2 raised to 1/2 times 2 raised to 1/3. Applying the laws of exponents, since we have same base, so we have 2 raised to 1/2 plus 1/3. Using butterfly method, 1 times 3, 3. 1 times 2 is 2. And then for the denominator, 2 times 3 is equal to 6. Therefore, we have 2 raised to 5 over 6. After that, we write the given expression in radical form. So 2 raised to 5 over 6 is 6th root of 2 raised to the 5th power. And 2 raised to the 5th power is equal to 32. Therefore, the product of square root of 2 and cube root of 2 is 6th root of 32. Multiplying radicals having different indices and different radicands. Say for example, we have simplified square root of 2 and cube root of 4. So if you will try to observe, each factor or the two factors have different indices and at the same time they have different radicands. So how can we multiply them? First thing that we need to do is to express each of them in exponential form. Square root of 2 is 2 raised to 1/2 in exponential form, and cube root of 4 is 4 raised to 1/3. After that, express the fractional exponent to similar fractions. So 1/2 has the same value as 3 over 6. And 1/3 has the same value as 2 over 6. So if you will try to observe, 3/6 and 2/6 are now similar fractions. After that, we will apply power of a product. So we have 2 raised to 3 times 4 raised to 2 quantity raised to 1 over 6. And then after that, write in single radical, or express this in radical form. This is now the sixth root of 2 cubed times 4 raised to the second power. So we have the sixth root of 2 cubed times, we know that 4 is equal to 2 squared and then raised to the second power. So we expressed 4 in exponential form. Therefore, we have the sixth root of 2 cubed times 2 raised to the fourth power. Applying the laws of exponents, we have the sixth root of 2 raised to the seventh power. Now, what is the value of 2 raised to the seventh power? 2 raised to the seventh power is 128. So we have the sixth root of 128. Think of a factor pair of 128, wherein one of them has a sixth root, and that is 64. So we have 64 times 2. The sixth root of 64 is 2. And then the other 2 will be left inside the radical sign. Therefore, the product is 2 sixth root of 2. Binomial radicals can be multiplied by applying the distributive property or special products of algebraic expressions. Example, simplify 2 square root of 2 times the quantity 3 square root of 2 plus 2 square root of 3. So we will simply apply distributive property of multiplication over addition. So we have 2 square root of 2 times 3 square root of 2. 2 times 3 is 6. And then square root of 2 times square root of 2 is square root of 4. Plus 2 square root of 2 times 2 square root of 3. 2 times 2 is 4. Square root of 2 times square root of 3 is square root of 6. Now we have 6 times the square root of 4 is 2. Bring down plus 4 square root of 6. 6 times 2 is equal to 12. Plus 4 square root of 6. This is now our answer. Let's have more examples. Multiply number 1 for cube root of 6 times 5 cube root of 9. So first we multiply 4 times 5. And then cube root of 6 times 9. 4 times 5 is 20. And then 6 times 9 is 54. Now using factor 3, let us simplify cube root of 54. 54 is equal to 6 times 9. 6 is 3 times 2. And 9 is 3 times 3. So we will look for 3 similar prime factors. We will write it once and then 2 will be left inside the radical sign. Therefore, the cube root of 54 is 3 cube root of 2. Now we have 20 times 3 cube root of 2. 20 times 3 is 60. And then we have cube root of 2. Therefore, the product is 60 cube root of 2. Let's have another example. Square root of x cubed y squared times square root of x squared y cubed. So we have x cubed times x squared times y squared times y cubed. Applying the laws of exponents, we have x raised to the fifth power times y raised to the fifth power. Split x to the fifth power in such a way that one of them is a perfect square. So we have x to the fourth power times x. Same with y to the fifth power, split it into two factors wherein one of them is a perfect square. We're going to have y to the fourth power times y. The square root of x to the fourth power is x squared. The square root of y to the fourth power is y squared. And then x and y will be left inside the radical sign. So the product is x squared, y squared, square root of xy. Let's have another example. Square root of 12 times square root of 27. This is equal to the square root of 12 times 27. And 12 times 27 is equal to 324. 324 is a perfect square, and the square root of 324 is 18. You may recheck using factor 3 method. So we have 324. 324 is equal to 2 times 162. 162 is 2 times 81. 81 is 9 times 9. 9 is 3 times 3. Let's look for pairs of prime factors. Write it once. So if we have 2, write it once, and then 3, and then another 3. So no prime factor will be left inside the radical sign. Let us now simplify. 2 times 3 is 6. 6 times 3 is 18. So we got the same answer. Therefore, the product of square root of 12 times square root of 27 is 18. That is how we multiply radical expressions. Thank you very much for listening.